Mobile communications networks are essential to our everyday lives. We use mobile terminals such as mobile phones and data card terminals in all areas of work and life. Operators worldwide have fully deployed 4G networks, and an increasing number of them are preparing to deploy 5G networks. As mobile networks continue to evolve rapidly, it's useful to take a step back and review their history. The beginning of modern mobile communications can be traced back to the 1970s, when Bell Labs in the United States proposed the revolutionary concept of cellular networks. In a cellular network, an area that requires signal coverage is divided into several neighboring cells, forming a cellular structure. A radio base station in each cell provides signal coverage to enable communication between terminals and the network. At the end of 1978, Bell Labs in the US successfully developed the world's first mobile cellular telephone system, the Advanced Mobile Phone System, or AMPS. 5 years later, AMPS was put into commercial use in Chicago, rapidly adopted throughout the US, and achieved great success. During the same period, other regions such as Europe also set up their own first-generation mobile communication systems. First-generation mobile communication systems were based on analog technology. System capacity was limited, such that networks could only provide basic voice services. In addition, finding ways to deal with security and interference were thorny problems for operators. Meanwhile, terminals were very expensive for consumers, with mobile phones a symbol of luxury and wealth. In the late 1980s, as the application of large-scale integrated circuit, microprocessors, and digital signals grew mature, mobile communication technology evolved to become based on digital technology, starting with the 2G era. Mainstream mobile communication systems in the 2G era included GSM in Europe and other communication systems such as CDMA in the US and elsewhere. 2G mobile communication networks provide basic voice, low-speed data, and short messaging services, or SMS. With the rise of mobile data service, third-generation mobile communication systems, or 3G, were developed in the early 21st century. Compared with 2G networks, 3G networks support the provision of high-speed data services. 3G uses Code Division Multiple Access, or CDMA technology, which increases network capacity to better support data services. 3G allows the provision of multimedia information services such as images, music, and videos. In this way, 3G makes it possible for users to easily browse websites, convene telephone conferences, and perform e-commerce on their mobile phones. The main 3G technologies include WCDMA, CDMA 2000, and TD-SCDMA. The names show that the three are all based on CDMA technology. The data rate on 3G networks can reach more than 1 megabit per second. Smartphones emerged in the 3G era, which further promoted the development of 3G networks, rapidly increasing the number of 3G users and making data services accessible to more people. However, because there were different 3G technologies, terminal and network compatibility had been a concern for operators and consumers. With the emergence of 4G, the LTE technology standard, which was introduced by the Third Generation Partnership Project, or 3GPP, became the unified global technical standard for mobile communications. LTE is short for long-term evolution. Compared with 3G, LTE adopts new network architecture and wireless technologies. This greatly enhances network capabilities and allows data rate of approximately 100 megabits per second. An upgrade of LTE, Long-Term Evolution Advanced, or LTEA technology, allows LTE to achieve a peak rate that is close to 1 gigabit per second through multi-carrier aggregation and other technologies. This means LTE can now achieve a data rate similar to that of the wired access service. Mobile broadband, or MBB, has gradually become a part of people's lives. 4G networks are now used to facilitate financial payments, shopping in trips, and social recreational activities, bringing more convenience and vitality to daily life. To summarize the history of mobile communications networks, then 1G gave rise to modern mobile communications. 2G brought about the transition from the analog to the digital era and availed the whole society of the convenience brought by mobile communications. 3G further boosts the evolution from voice to data. Additionally, 4G greatly improved network bandwidth, popularized data services, and greatly increased the applications and value of mobile communication networks. Looking to the future, what new features and services will 5G networks bring? First, one target of 5G will be the continuously increasing data rate. Compared with 4G networks, which have a target peak rate of 1 gigabit per second, 5G networks will continue to increase the data rate for supporting new services in the future. Second, 5G networks development will focus on creating a fully connected, intelligent society in a way that will greatly improve humanity. This is in contrast to the development of previous mobile communications networks, which focused on facilitating better communication among people. 5G will greatly improve the connectivity of networks. Low latency is another important feature of 5G networks. 5G networks' low latency will facilitate automated driving and the automation of industrial manufacturing, which have strict network latency requirements. With its powerful network capabilities, 5G will support more industries, create an end-to-end ecosystem, and build a fully mobile and fully connected society. The birth of 5G will lead to a new information technology revolution, with significant improvements to people's work and lives. Let's look forward to the bright future.